Kia ora Year 12 and Year 13. In this video I'm going to go over some more identities. If you're from Wellington College and you're watching this, these are from Mr Hurring's extra sheet with 10 little identities on them, and the task is a little bit different from our usual one. This time we have to see if in fact they are identities, or if we have to think about how we can change the equation to make it into an identity. So in this video I'm picking off numbers 1, 2, 3 and 6 from that sheet. If you're from a different school or you've lost your sheet, it doesn't matter, you can just watch and do them with me. Make sure you've got pen and paper ready to go, and I'm going to do a separate video with 2 of the harder ones from this sheet. So these ones are focused on just getting used to what we're doing when we do an identity, so it's going to be quite slow. Okay, the first one that we're asked to look at is to say whether it's true that sine of x is equal to cos of x times tan of x. Right, if you want to check that that's going to work out to be an identity before you start, you can grab your graphics calculator and graph both sides of the equation, or you can apply a little bit of brain and do it using what we know about trig ratios. And in this one, we're going to start on the left-hand side, and we're going to try to get to the right-hand side. No, we're not. Now, why is that a bad strategy? Well, I can't do anything with sine x, so I want to start on the side that is going to give me stuff to do. So we're going to ditch that, and we're going to start on the right-hand side. So it doesn't matter which side you start on, as long as you're working very logically to get from one side to the other. And the goal with the proof is to communicate your thinking really nicely so that a reader can follow what you were doing. So cos x, tan of x. It's never enough just to say, oh yeah, it's true. Right, so we're going to do cos of x times sine of x over cos of x. And cos x over cos x is 1, so that equals sine x, which is the left-hand side. So some of the conventions that we follow when we're working with proofs, this one here, we start by saying which side we're starting on, and we say, hey, I've got there as finished. And you can write a couple of things at the end. You can write as required, or if you want to be old-fashioned, you can write QED, and you can find out what that means. Or you can draw a smiley face, not recommended for internals. Okay, on to the second one. So they're cranking up a little bit. This one is 4 cos squared theta minus 2 equals 2 cos 2 theta. So we're going to use our double angle formulae here. So this time we'll start on the left-hand side. So we write down 4 cos squared theta minus 2. And we take a look and we say, well, what's the only thing I can do there to get started? I look at my 2 numbers, and I've got a common factor of 2. So I take that out. So 2 watts will give me this, 2 times 2 cos squared theta minus 1. So I do that, and hopefully now I recognise, or I reach desperately for my formula sheet and see that that is the cosine of 2 theta. Right, so just a really quick refresher, cos 2 theta has got 3 different versions. And they come in extremely handy when we're doing trig proofs. These are the 3 versions. And doing harder trig proofs is a bit of an art in that you have to look where you're going and make smart choices about which thing we pick here. Okay, so that's that one done, and we found that this is true. So this statement is true for all values of theta. Right, now the next one is question number 3. And we're asked to show that this is true. So you might want to pop this one into your graphics calculator and see what you find about this side and this side. And what you'll see is that they're not the same. Now I want to go through the identity stuff in this video, so I'm not focusing on the graphical features, but just have a look at what makes those two functions different, and now we're going to show it using our rules. So we've got the left hand side, we'll start here, and we've got 3 over 2 cos of 2x plus 3. Now I'm looking at the cos of 2x and I'm wondering which one should I pick. I've got 3 to choose from. So to make that decision, I look to where I'm going and I see I want to end up with a cos squared x. So that's how I decide that I'll use this version of cos 2x. Okay, so I'm substituting the double angle in. That leaves me with 3 cos squared x minus 3 over 2 plus 3. So that equals 3 cos squared x plus 3 over 2, which is not equal to the right hand side. So what do I have to do to fix up this to make it into an identity? Well, I just have to change the plus 2 to a 3 over 2. So 3 over 2 cos 2x plus 3 is equal to 3 cos squared x plus 3 over 2. Okay, so that statement is a true one, true for all values of x. Okay, the last one I'm going to do in this video is number 6 from the sheet. So this is it here. So this is a little bit trickier. We have to think about how to break up the left hand side. So we want to see if this is an identity, true for all values of x. So we're going to start on the left hand side here, and we're going to write cos of 3x, and we look and we can't find a triple angle formula. So we're going to have to use our general compound angle formula, which is the cosine of a plus b. So the cosine of a plus b is cos a cos b minus sine a. Oh, sorry about the background noise. I'm trying to do this with the kids running around. So this is what I'm going to use to substitute. So that's the first thing to spot. The second thing is, how can I break up my 3x? Well, I'm going to split that into a 2x and an x. Right, so we start on the left, and we're going to magically clean up that stuff down there in a minute. So pause the video and go as far as you can with this clue. So cos of 3x is equal to cos of 2x plus x. Now you're going to need to use your double angle formula, looking where you're going to choose intelligently. So pause it, have a go, and then come back and please come back and watch the rest of the video. Okay, so this is what we get. Cos of 2x times cos of x minus sine of 2x sine of x. Now hopefully you didn't write all of that stuff in the middle of the page in your maths book like I just did. We're just going to hop down to here, and we're going to now expand out this, choosing wisely, and this. So we get 2 cos squared x minus 1 times cos x minus, now when I look at the sine 2x, this is a really good one to see when you're doing identities, because there's only one smart thing to do, and that's to use 2 sine x cos x times sine x. Right, I've got very slack in here with the brackets around my angles. That's better. Kind of fixed up. Now, we're just going to expand a few things. So a little bit of work to do still. This times this will give me 2 cos cubed x. This times this gives me minus cos x. And now sorting out this, I get minus 2 sine squared x cos x. Right, now I'm going to take a new slide. I want you to pause and see if you can finish it off from here. There's one more little identity from way back at the start of trig that you have to use. Okay, so we've got down to here, I think. We've got 2 cos cubed of x, that's right, minus cos of x. I'll just get rid of that bracket, we don't need that. And I'll get rid of that bracket, sorry guys, there we go. Minus 2 sine squared x, sorry, you are getting the violin practice in the background now, just bear with it, let's hope it's good. So 2 cos cubed x minus cos of x. The last thing we got to do is to switch out the sine squared x. So we know that sine squared x plus cos squared x equals 1. That means that I want to have something with cos and no sine in here. So we're going to use this. Sine squared x is equal to 1 minus cos squared x. And it's the last bit of substitution coming up. So we'll do that in blue. Minus 2 cos x times 1 minus cos squared x. And we're nearly there. And that gives me 2 cos cubed x. Guys, I'm really sorry about that noise, but I have just not got time to redo this video. So just bear with me. Hopefully she won't play any bad notes. There we go. Right, so the expanding out in here, I'm doing the 2 cos x times each bit in there. Now, putting the like terms together, I've got 4 cos cubed x minus 3 cos x as required. Alright, thanks very much for watching and for letting me know, of course, if there are any mistakes. And also please email me and tell me if there's any other ones you'd really like me to do in the next couple of days.